Okay, so this is uh, the class for Wednesday, November 15th. Okay? And what I'm going to talk about today is the rest of the material that covers the topic of archaeometry, which we started on Monday. So archaeometry, again, is the use of high-tech scientific techniques for archaeology. So we talked a little bit about identifying fake artifacts as a potential use for archaeometry, but it's not always 100%, right? You can see if an inscription was added later. If the patina and the inscription, the patina on the outside of the object are not the same, then it shows that the inscription was not original to the piece. But if you just have a statue, a marble statue, and you figure out that the marble is, in fact, from where it should be, it doesn't necessarily prove that the object is authentic. Okay, so now we're going to talk about a couple of different techniques that archaeometrists use. Right, one of the most important techniques is called elemental analysis. Right, and I'm sure you guys know what an element is, but it's the smallest unit of a substance. So you look at the periodic table and you see all the elements that have been identified. Right, well, if you take a substance like obsidian, the volcanic glass, and you conduct this kind of analysis, you can look at the amount of different kinds of elements in the obsidian, like rubidium, zirconium, you can see here, manganese, iron, right? There's lots of different elements that you can examine. Now, the good thing about obsidian is that each source is chemically different from each other, right? And if you have artifacts from an archaeological site, that's what you see here, you can do this elemental analysis, and because each source has different proportions of elements, you can figure out where those artifacts came from, right? So you can say, all right, this group corresponds to that group, this one corresponds to this group over here, this one corresponds to about this group over here, right, that purple one. Sometimes they're a little bit hard to discriminate, like there's a little bit of overlap between some of them, right? But looking at the proportions of elements allows you to source and figure out the geographic and the geologic origin of different kinds of artifacts. And so this has been used in many areas throughout the world, most importantly in the Maya area, right? You can see that different substances have been traced to different regions. You can look at ancient trade through time, so it's a very important technique, right? And for something like obsidian, that works great. But for other objects, you can't really do it that way. You might have to do something else. So, for example, pottery. Pottery gets a little tricky. Instead of looking at elemental analysis, what people do with pottery is they look at the different minerals in the clay, right? So pieces of quartz, pieces of basalt, pieces of mica that are naturally occurring in the clay, right? You can identify these minerals by cutting a thin section of the sherd and putting it under a special polarized microscope. And what the polarized light does is to make different minerals show up as different colors, right? So here is something like basalt under plain light. Here's basalt under polarized light. Different minerals show up as with different properties, different colors. So if something is purple and pink, you can tell it's one kind of mineral. If it shows up as blue, it's a different kind of mineral. And if you look at the proportions of these, again, what you would do is you would try to get clay from the area, and then you would take your pottery and you would compare your pottery to different clay sources and see if you can match it up. Right? So this is a different technique. So here's what basalt looks like under the microscope. Right here you can see some different minerals here showing up as different colors. The stuff that they're in is the clay. This is a thin section, so they would actually slice a piece of pottery extremely thin so that light passes through it, right? And this gives you an idea of some Canaanite vessels from a particular site. I think this is in Egypt, right? And you can see that there's a lot of variation in the kind of minerals in these clays, right? So you can figure out, okay, were these vessels from different areas from all around, or were they from one central area, right? So petrography, think of petroglyph or you know, the prefix PETR stands for rock, right? Like petrified, right? So petrography is the study of these rocks and minerals in the clay. So that's one way to remember it. Okay, residues. Right? So this is another great area of interest. This is one that's been in the news recently as well. If you, let's say, take a residue and you break it all the way down into its elements, then you're getting too small, and you're not going to be able to tell what the substance was. You're just going to look at, okay, there was carbon, there was hydrogen, there was this, but you don't see what the actual substance was. So you don't want to get that small. You want to look at compounds, right? The combination of elements. And the way you study this is with something called mass spectrometry, right? That is, it breaks up a substance by mass. Things that are heavier in mass are at the end of the spectra, and things that are lighter are closer to the beginning of the spectra. Right? And so if you, let's say, find a residue inside a pot, you could conduct this analysis and you'll get something like this, right? And it's telling you the molecular weights of the different compounds. Based on the molecular weights, you can identify what substance it was, right? And that's essentially how it works. It breaks this up by mass using a magnetic field, right? So what you can see is that, lighter substances come out first, heavier substances come out second. They've done this many times in many different kinds of artifacts in many different areas, and I'll just give you a couple of examples. Right, here's a nice vessel from the Maya area. It had the name of the elite person on it, and it also had the Maya glyphs that spelled out cacao. Right, cacao, is chocolate. Right, well, there was residue inside here. They sent it to a lab. I think it was actually the Hershey lab in Hershey, Pennsylvania, that analyzed it, and lo and behold, using mass spectrometry, they saw diagnostic compounds of chocolate, right? So there was cacao in here, and it said cacao on the vessel. Right? So this is just a lot to try to understand the chemical properties of different substances and also identify residues, especially from pottery. Right? So if you can figure out, okay, people were using milk products by this time, people had beer by this time, right? It really gives you an interesting perspective on technology over time. And one particular individual who's really been important in this work is this guy over here. You can see his name's Patrick Mcgovern. He's identified the earliest evidence for beer, dates to 3500 BC, and just recently, this was just in the news a couple days ago, he was involved in a project where they said they found the earliest evidence for wine. It's the earliest wine ever found. It dates to about 8,000 years ago. It was found on pottery from the country of Georgia, and he used, again, this mass spectrometry. He found compounds on the residue inside the pot that are specific to wine, that show that it was fermented. It wasn't just grape juice in there. It was actually fermented wine. And he's also worked with, you can see the Dogfish Head Brewing Company, and they've reconstructed some ancient beers and ancient wines and things like that. One of the most notable, and you can buy this beer locally, it's called the Midas Touch, and it's a recreation of the beer that was in King Midas's tomb, which you can see here in Turkey. There was a real King Midas, and this is his actual tomb. And then they found residue on the inside of the pots, and they figured out proportions of different compounds in there, like apricots with the barley and things like that. Okay, another important use. So that's That's mass spectrometry, right? Okay, so far we've looked at elements, we've looked at rocks, we've looked at compounds, right? Now we're going to look at isotopes. We've talked about isotopes already with C14 dating, radiocarbon dating. Those are radioactive isotopes. You have isotopes, everyone has isotopes, and there are isotopes that exist in every substance that are not radioactive, right? They're stable isotopes. They don't break down over time, right? Well, these stable isotopes can indicate to an archaeologist what the diet of the animal or the diet of the person was, right? Because isotopes are found in different concentrations in different plants. So, for example, if, let's say, your bones, after you die, were found by an archaeologist, and then the nitrogen isotopes and the carbon isotopes were analyzed, archaeologists can figure out where your diet, what your diet was like over your lifetime, and where it fit in this spectrum, right? So, for example, C4 are plants like corn. C3 are plants like wheat and barley, right? But you could also see the nitrogen helps you determine if you had a marine diet or a more terrestrial diet, right? So here you can see, for example, this is the Inuit who live in the Arctic, the Haida live in the northwest coast, big marine intake, right? Not too surprising. The Danish Mesolithic, right? They were eating lots of seafood. Here in Tehuacan, prehistoric Tehuacan, where this is in Mexico, they were eating lots of corn, right? The beginnings of agriculture in Europe, you could see lots of wheat and barley. But it's different from Britain, where they had more of a marine diet added to that as well. And in Denmark, they had even more of a marine diet and less of these C3 plants. So you can look at change over time. You can look at change between different areas, right? Terrestrial versus marine, right? Different kinds of plants. So it's very, very useful. And you could compare within a population, let's say the elites versus the non-elites, where they're eating different kinds of things. So those are stable isotopes, right? Okay, you're going to see a video. This is going to be one of the assignments about Viking swords. And they're going to show you some very basic archaeometric techniques that they use to analyze it. So the study of metals is another important archaeometric technique. And we're essentially using stuff like elemental analysis, or you can simply look at thin sections under the microscope. Right? So they did this kind of analysis on the Liberty Bell. Liberty Bell was cast in England, brought to Philadelphia. It cracked, right? Then it was melted down and recast, and actually cracked again. They didn't recast it, they just repaired it, and it stayed there in Independence Hall in Philadelphia. Right? But they analyzed the Liberty Bell, and they took samples from different areas. And what they saw is that the samples were not consistent chemically. Right? And so you might ask, okay, well, what does that mean? Well, it's not homogeneous. So what they think is that when it was recast in Philadelphia, they didn't have a crucible big enough to hold all the metal for one single casting, that they actually had to mix it up in batches and keep pouring using different batches. And because there were different batches, it was not consistent chemically, and that's why you have a difference. Whereas if it was all cast in one session where they had a huge crucible with all the bronze and then poured it, the whole thing would be homogeneous. Okay, if you guys have ever done 23andMe or anything like that, you know that DNA is also a very important part of archaeometric analysis, right? So now what they use it for, and this is the older version of that kind of test, the genographic project from National Geographic. They could use markers on your DNA and match it up with ancient prehistoric populations and figure out, what percentage of your background was from one area or another at different times. But they could also look at ancient migrations of people through time. So it's become a very important resource for archaeology, right? I did this with my DNA, and I got back, this was years ago though, so it will be much improved with new technology, but they said based on my Y chromosome. I was descendant of a Middle Eastern clan, someone born between 15,000 and 10,000 years ago in the Fertile Crescent. The census man played a crucial role in modern human development. They pioneered the first Neolithic revolution, point at which humans changed from nomadic hunters and gatherers to settled out agriculturalists, right? So you can see you can trace things back to different stages. But you could use this on things other than humans to answer different questions, right? So you might recognize this. This is the Dead Sea Scrolls found in the caves here near the Dead Sea in Qumran. And there's been debate about the Dead Sea Scrolls. One theory about the scrolls is that a community in this area wrote all of the scrolls and then hid them in the cave during the Roman period. Another theory is that scrolls were collected from all over ancient Judah and brought here for safekeeping. So these scrolls are made out of animal hide, right? Usually sheepskin. And they wanted to see, okay, were these all from one area or were they from different areas? So if it was from one area, you'd expect that it would be one flock, and that if you analyze the DNA, they would be pretty closely related to each other, right? The actual DNA from the animal skin. If they're from all over Judah, then you would find that they were different genetically. And they tested it, and what they found is that they were all similar. So all the scrolls are probably from one group that lived in that area and that put the scrolls in the cave. Right? Okay, so let's just review quickly. So trace element analysis, you're looking at elements. You can do things like sourcing obsidian. Petrography, you're looking at rocks, and usually it's rocks under a special microscope. And you can look at rocks in clay, and you can source pottery that way. Mass spectrometry, right? You're looking at the mass of compounds, and it's giving you an identification of things like residues. Right? Carbon isotope analysis, nitrogen isotope analysis, you're looking at diet through an analysis of the isotopes in the bone. And genetics, right? You can look at migrations of people and relatedness. Right? Okay, so that's archaeometry. We're going to talk a little bit about forensics now, and then I want you guys to watch a film that I'm going to put on Blackboard showing an archaeometric analysis of Viking swords, and it gives you kind of a nice insight into how archaeometry works, and it's an interesting video as well, right? But let's take a look at forensics briefly. Right? Okay, there's a couple of topics that are connected: forensic anthropology, bioarchaeology, osteology. These aren't the same thing, but they deal with human bones. Forensic anthropology is specifically the study of human bones for legal matters, right? So whenever you're talking about forensics, you're talking about things that are involved with court cases. Right? And so anthropologists use forensic anthropology for police investigations, human rights abuse trials, war crimes, etc. Right? So if you can't identify the person based on the remains because there's no muscle tissue left, there's only bones, you would bring in a forensic anthropologist. You also bring in a forensic anthropologist to show cause of death, right? So if you find a mass grave and you're trying to prosecute someone for a war crime, you want to be able to show that those people were executed. Right? They didn't die naturally, and they didn't die from a disease. They were actually, let's say, shot in the back of the head or something like that, because that's important in any criminal case. This guy, Clyde Snow, I don't think he's around anymore, unfortunately, but he was very prominent in this field. He prosecuted or helped prosecute war crimes in Argentina and Bosnia and elsewhere in the world. Right? Okay, typically bioarchaeologists deal with a few parts of the skeleton. They usually divide it into the cranial and the postcranial skeleton. Right? The skull is good for identification, not only because you can do facial reconstruction, but because the teeth are the most durable part of the skeleton, and teeth are a very good way, especially in recent times, of identifying an individual, because dental records are very good. Okay, so the skull, you have the cranium, right? So this is the top without the lower jaw, the mandible. The cavallarium is the skull without the facial bones, and then of course we have 32 permanent teeth. The postcranial skeleton, long and limb bones, right? Short bones, right? The pelvis. We're going to talk about some of the things that you can do with bones, right? There's a lot you can tell from human remains, right? And one of the things is sex, right? So you can figure out if it was a male or female, not with 100% accuracy all the time, but you can get pretty close. The age, again, you can get pretty close based on the fusion of the bones. The stature, right? Since things are usually in proportion, if you find a long bone, you can measure it and extrapolate from there how tall the person was. You guys are going to do that in the lab, hopefully on Monday, right? Race, as you can see, very problematic. You can get a little bit at possible geographic origin, right? But race is a problematic category, anthropologists like to say, because it's imposing rigid classifications on traits that are clinal in distribution, right? That show gradations across space, and so these classifications are arbitrary. They don't take into account the variation that occurs within each of these categories. But there's some, and there's, you'll see some textbooks that still use these really outdated terms. I just have them up here so you can see, right? But most people don't use these terms anymore, but you will see them in textbooks sometimes. But one good marker for, let's say, geographic origin could be the incisors. It turns out that Asians, and some Native American populations have a shovel shape on their incisors, right? So instead of having a flat back to the incisors, there's kind of an indentation, right? If you find that, that's usually a good indication that the person was of Asian or Native American origin. Okay, okay. Dental records, again, are very, very good. You can look at the possible identification of the person. Right? Sex. How do you tell this? Well, you guys will see it in the lab, but one way is the pelvis. Female pelvis is shaped differently, usually has a wider opening, right? And also the skull. Right? Males tend to have a more prominent brow ridge. Females tend to have a less prominent brow ridge and a flatter forehead. Also, the orbits. Males tend to have a more square orbit. Females tend to have a more rounded orbit. So that's another way of telling. Right? As we're going to see, there's also lots of diseases that you could look at in the bone. So you can tell, did this person suffer from a certain type of disease? Did they have an injury that healed? Did they have an injury that killed them? Did they have wear on their teeth from a certain kind of diet? You could tell, again, the timing of the pathology. So did they have something that healed, right? Like a broken bone? Did they have a cut mark on their bone that was around the time of death that might have caused their death? Right? That's perimortem. Postmortem would be something like a break way, way, way after the person's dead from, let's say, the deposits getting moved or something like that. Okay, so there are many diseases you can see on the bones. Osteoporosis, right, where loss of calcium in the bone. Arthritis, where there's no cartilage in between the bones rub up against each other and form scar tissue, right? So here's some arthritic hand bones, and you can see that there's a lot of scar tissue near the joints, right? This is why people with very arthritic hands have those kinds of swollen joints, because the bones are rubbing up against each other without the cushion of cartilage, and it's producing that kind of scar tissue, right? Trauma. Okay, here you can see this is a long bone that was broken and healed, right? So it was a fracture that healed. Gunshot wounds, right? Entry and exit wounds, right? You guys probably know, because you've seen it on forensic shows and things like that, that the entry wound is small, the exit wound is larger. You can see the angle here. It's a little bit like the bulb of percussion with lithics, right? There's a point of impact, shock waves radiate out, and that's why you have a larger hole at the back. It's not just the bullet, it's also the shock waves pushing out the back of the skull. Ancient surgeries. This is one of my favorite topics. Ancient surgeries that were performed by ancient people where people actually survived, right? This is an ancient surgery called trephination. This is where they would remove part of the skull, and there were different ideas around why people did that. But you could see that there's already some healing here. Right? These are tools that were used in South America, and this is someone performing this trephination in South America. Right here you can see healing over, right? So there, this is healing of trephination. Here's some other skulls that show trephination. You can see it looks like they drilled several small holes to remove that piece. And here you can see the skull beginning to grow back. So this person survived that surgery, right? And this is a surgery that has been performed throughout the world. You can see here at different times. What they think is that in many societies, let's say you got hit on the head, and there was hemorrhaging, bleeding on the inside, right, of your brain, putting pressure on your brain. You would start acting strangely. Ancient people usually interpreted this as possession by a spirit, right? So you're acting strange because a spirit was possessing you. So what do? You have to get the spirit out. So what they would do is make an incision in the scalp, push the scalp back, make an exit for the spirit to leave the skull, right? And actually what they would be doing is allowing the hemorrhage to also be released. And so there would be a practical medical application for this, right? But then they, according to their beliefs, the spirit would be gone. They would push the flap back, and the person would heal, right? And so this is occasionally still used today, this surgery, although not this way anymore, right? Another thing you can tell is if the person was elite or not. Usually, and you saw this in the video about the Maya and Copan, right? Elites had this cranial deformation, right? That is, the babies were put in a cradle board or had their heads bound when they were young so that their heads would grow in this shape, and this was a mark of elite status, right? Okay, well, I think we will talk more about this. We'll talk about some diseases on Monday and hopefully get to do our lab, right? And this will give us, again, some more background on the different kinds of things that you can do with forensic analysis.